Good morning, everyone, and welcome to the sixth installment of Katia University. Today we'll be discussing wire harness and other electrical processes within the Dassault Systems products. I'm Susan Crowden, and I'm your host for today. I have with me today Glenn Larson, also from Vias 3D. I have our two presenters for today, Zhen Yang from Dassault Systems, along with Pascal Fontany. Next slide. For any of you that have been here before, we start with the good stuff. First, yes, at the university, there are graduation gifts. We're expecting everyone to pass with flying colors. So do stay until the end, because if you do stay until the end, you'll be entered to win a $50 Visa gift card, but you must be present at the end to win. Also, for anyone who participates in all 7 of our classes, you'll be entered to win either a Space Mouse or an iPad, your choice. 5 lucky winners will be selected. Next slide. Who we are at Vias 3D. We are a Dassault Systems Platinum Partner, last 3 of the last 5 years. We're also a Dassault Systems Education Partner. We have multiple industry experience in oil and gas, aerospace, nuclear, manufacturing, automotive. Our team consists of more than 100 employees, with many being PhDs, or MSc, MS Techs in design, manufacturing, structural mechanics, fluid dynamics, electromagnetics, etc. We provide engineering and PLM consultancy, training, software sales support, automation, and customization. And we're a global provider with representation in the United States, Canada, Mexico, India, and we have recently opened our office in Turkey. Next slide. Who is Dassault Systems? For any of you on the call who are not familiar with Dassault Systems, they're the leading developer of CAD, CAM, and CAA software around the world. Their product family has more than 120 interrelated software products, serving 11 industries such as transportation, aerospace, marine and offshore, industrial equipment, high-tech, home and lifestyle, consumer packaged goods, construction, cities and territories, and business services. They help in enabling implementation of design, analysis, manufacturing, and post-production of support systems. They have more than 22,000 people around the globe. They have 12,600 worldwide partners, of which Vias has 6 or 8 of those slots, with more than 290,000 enterprise customers, and they're about $5.4 billion in sales, so not a small organization. Next slide, please. Our value at Vias 3D is to provide, through the application of digital technology, enabling manufacturing and engineering organizations to become better at connected collaboration, process discipline, and digital product experience. We use digital transformation using the 3D Experience platform technology. It has social and collaborative apps. You can see here on this compass, 3D modeling apps. Push the button. Yep. Simulation apps. Information and intelligent apps. And all happening real time on the 3D Experience platform. Next slide. So today, our key takeaways for the class are, number 1, to discover what's new in the CATIA Electrical portfolio for 2022X, to learn more about CATIA Electrical Systems engineering solutions for those of you who are not familiar, and finally, to watch an end-to-end demonstration of how to use electrical rolls on the cloud and on-premise. Next slide. I'd like to introduce our two presenters. Our first presenter will actually be Zhen Yang. Zhen is the Senior Technical Consultant at Dassault Systems. He has 15 years of experience with Dassault Systems and 11 years of experience in the CATIA Electrical portfolio. Since joining Dassault Systems in 2011, Zhen has worked with DS customers from all industries in North America to provide solutions and maximize ROI on electrical and electronics disciplines. We also have with us today Pascal Fontany. Pascal is the CATIA Electrical and Fluidic Senior Industry Process Consultant at Dassault Systems. That's a mouthful right there. He is responsible for supporting sales activities for CATIA Electrical and Fluidic. He has over 20 years experience in electrical design and manufacturing in aerospace. Before joining Dassault Systems in 2018, he worked for 15 years at Gulfstream Aerospace in the PLM organization as a solutions specialist for electrical and CAD development. And with that, I'm going to pass this presentation over to Zhen Yang. Zhen?
All right, thank you, sir. All right, let me know if you see my screen.
Yes, we see it just fine so far.
Excellent, excellent. Thank you so much. All right, so thank you guys for joining this webinar. And in this session that we would like to give you a detailed explanation of what 3D experience covers in terms of electrical engineering. For this webinar, we will begin with the short introduction to the electrical industry segments covered by 3D Experience electrical portfolio. We also talk about the market and industry trends and the challenges that our customers are having. In the next session, we will explain the Dassault Systems vision, strategy, and offerings to cover the complete process and provide the benefit this will have for our customers. The process is further illustrated by a customer case from an ongoing major aerospace and defense OEM engagements that we have today. It will be followed by a live demonstration by my colleague Pascal. The demonstration will cover the core electrical end-to-end process from schematics to 3D harness design to manufacturing documentation. And finally, we'll provide a summary at the end. Within Dassault Systems and the industry, we see mainly three types of electrical systems. First, wire harness. Second, the cabling. And then electrotechnical. The wire harness is assembly of connectors, wires, and cables, as well as additional components bundle them together, such as coverings, fixtures, etc. These are mainly found in automotive, aerospace, and industry equipment disciplines. Cable systems consist of cables, and these are most one-to-one connections in a larger structure. And the cables are more often placed in cable trays, raceways, or hangers. And these are the physical elements you see on the screenshots here. Main industry for cablings are marine, offshore, energies, and the material like the plant design or industrial equipment in some cases. And the last segment is the electrotechnical. It deals with machines, cabinets, panels, and things like that. And this can be found in almost any industry where cabinet and the panel are used. And this is typically a use case of combination of wire harness and cabling within a very structured space. For this presentation, we will concentrate only on the first segment, which is the wire harness. We'll try to cover the engineering and the manufacturing of this in both aerospace and the automotive industry. Seeing more and more hybrid or electrical and autonomous intelligence vehicles with the ever-increasing electronic systems, it is not surprising to see more complexities, higher amount of electrical systems, including the wire harnesses, and at the total cost of electrical and the electronic system, including software, is taking a significant part of a total vehicle cost, for example. And these numbers that's listed here can be found from several sources. And it just shows that how important electrical is becoming as a key topics for our customers, besides, of course, the traditional mechanical design. If we look more specific at the challenges this brings to our customer, we can see the challenges from the market, like the cost, quality, and the shortened time to market in a very competitive world. We'll see product challenges to have an accurate description and up-to-date information along with the process and avoid expensive physical mockups. Process challenges to reduce the number of applications and the platforms and avoid changes late in the process that will be very expensive. Traceability or digital continuous is becoming a more and more critical subjects with the complexity of the system. There are always simulation challenges in wire harness, both on the mechanical side and the electromagnetic side. And finally, there are manufacturing challenges such as supplier collaboration, digital continuity from engineering to shop floor operation, process planning, and the work instructions. If we look at currently a very simplified implementation that we see at many of our customers today, the harness process are covered by many applications, each of them with their own database or is simply file-based. The communication and the collaboration between the applications are very poorly defined and in most cases manual. This means that there will be never up-to-date information available, as indicated by one of our customers, that as soon as we are working on a manufacturing drawing, the design is already 6 months old. These kinds of implementation can never address the challenges that our customer is having, as explained here. So to enable our customers to have a more robust and integrated system, we will show on the next session the 3DS or the systems vision and the strategy. So our vision is to provide an end-to-end integrated electrical system engineering collaborative development platform to make sure that our customer can develop the most complex wire harness with the right quality within the shortest time and the lowest cost. The process has to be end-to-end because it is essential to cover the full process from requirements up to the wire harness in the vehicle as installed. The process has to be fully integrated because any data migration or duplication will prevent us to achieve full traceability and the additional data loss. The process has to support system engineering because this is the core of many customers to have this very well-defined approach to solve the complex system problems that we have today. The system must be collaborative because electrical system like wire harness is touching almost every part of the design, and it has to be worked throughout the development process with collaboration between the different disciplines. We also need to collaborate with requirements and the manufacturers and other stakeholders to ensure the success of the harness assembly. And the last but not least, it has to be a single platform because only a platform can help to integrate all the process and with consistent data and the full traceability. With 3D Experience Platform, we want to provide the continuous collaboration to accelerate the development and promote innovations, and serve as a single source of truth for even the most complex wire harness design. Here, let's take a closer look of the Dassault vision. In this view, we try to cover the full end-to-end process of wire harness design, starting from the stakeholder needs, which are the requirements. The requirements are decomposed and analyzed by system architects, where it defines all the EE components. Through the acquisition of NoMagic, we are now having a solid tool to define the system architecture and perform the what-if analysis. As you may know, that the NoMagic is also one of the standard requirements, standard required by the defense industry. With the system architecture, we are now able to collaborate with the 3D topology inside the CATIA design. The design will start with a high-level pathway or space reservation to integrate with the signal design in the platform from the net diagrams. This will enable us to perform net routing to take into account different requirements such as EMI, separations, and the maximum length and all that. From here, the 3D design proceeds to the detailed wire harness design, while the net diagrams is progressed to the wiring diagrams, where the disconnects are defined and the actual part number are selected. Through the logical to physical synchronization, we ensure at any time that the 3D design are fully synced with the 2D design with traceability visible on the platform through the traceability applications. With Simulia brand's CST Cable Studio, we are now able to perform the various analysis such as EMI and the EMC on the harness design. The 3D harness then can be flattened into the 2D to generate either a foam ball, which is one-to-one, or a documentation, which is not one-to-one, but with dimensions and annotations, which should be shared with the supplier. The same 3D data that's been used for the foam ball or the 3D design can drive the manufacturing process and the process planning and the work instructions in their mill product, again, from Dassault Systems. Here, the same data or the up-to-date design data directly drive the manufacturing process. And everything you see here is on top of the single source of truth, the 3D Experience Platform, which provides the global configuration and data management for all the processes. On this slide, I would like to give you an example of an ongoing customer case. And this is with one of the major A&D, aerospace and defense OEM in North America. And in this case, customer is required to work with NoMagic as part of the defense requirements. And this is where the system architects, where, for example, the LRUs are defined for each system and subsystems, and where they are located in the aircraft are also defined. And in NoMagic, the net level information are also provided for analysis. In the 3D, we collaborate with the system architectures through the aircraft zoning and the equipment space allocation, which allows the system 3D architect to place the preliminary design preliminary equipments inside the 3D space and perform space analysis. And with the space allocation applications, you can perform things like zone study and not just the geometrical, but also functional zones. The pathway is defined in the 3D space to estimate the volume required for each system. And in this case, we are only looking at the electrical system, but it's also possible to perform the same for fluid system as well. From the pathway model, we import the net definition coming from Cameo. And this allows us to perform the signal routing inside the 3D space of the pathway. And this will give us a preliminary analysis such as the fullness of the pathway, the separation between different signals, and what are the production breaks the signals are going through. And in the meantime, the information of the net can be used to generate the deliverables such as net diagrams. And this is a fully automated process. From the net routing and the topology information, the wiring data is provided and generated from the platform with standard parts selected automatically from the database from the specification of the net. And from there, we go into the detailed harness design and the manufacturing documentation. Like I said, this is ongoing project, and we are validating our process and continue to improve our process with collaborations with customers. Right. So next, we will have a live demonstration, and in this case, we will show the core CATIA Electrical process from wiring diagrams to 3D design to manufacturing documentation. And we focus on the digital continuity and the information flows throughout the process. And now I would like to switch to Pascal Fontani, who will give the live demo.
Thank you, Zen. So can you see my screen, the 3DX screen?
Yes, we see it.
Okay.
We see it quite clearly. Thank you.
Thank you. So thank you for having me. So like Zen was just saying, I will do a live demonstration of the end-to-end electrical process with core CATIA capabilities. So from the schematic to the 3D model, and then I will finish with a flattening process, mostly the documentation one. So as you can see, I'm not starting from scratch because of the time limitation, but I will enrich this diagram, and then I will, from the diagram, I will use the logical to physical assistant to position parts directly from the diagram to the 3D model. So now I'm going to, I'm going to switch. I'm going to hide the 3D geometry, and I will add the grid and the snapping grid that will help me to position equipment, connectors, and cables in the diagram. So as you can see, I've already have some equipment already positioned, so that we call the LRU, so it's defined as an equipment. We have some connectors. On the harness side, we have cables, twisted pair, things like that. So in this process, I will use two different techniques to place parts in a diagram. So I will use the catalog function, and then I will use the placement of existing parts already placed in a schematic, and I will use the creating from existing function to place these parts. So now in the first step, I'm going to place another equipment. So I will use a catalog browser. So you could access the catalog browser from all these apps or function at the bottom of the screen, but there is something called action pad, or you can add all the functions that you use very often. So like that, you don't have to switch between different tabs. So I'm going to place an equipment from my catalog. So usually this catalog is managed by a standard parts organization in the companies. So I'm going to place it. So you double click or you can do right click, insert. So the first time you instantiate one, it takes like a few minutes, sorry, a few seconds, because the first time you are accessing the database. Here we go. So you can zoom in, you can place it in space, and at the same time, you can type the instance name, or also known as instance title. So you validate, and then you will see that's a name. And then if you scroll down in a tree, you will see that your equipment is already placed here. So you can resize your equipment. So this equipment is coming from this catalog. So it's out of the box representation of the equipment. But if you want to have your own representation, it's something you can do. So we have a 2D representation for each part, but I'm using the out of the box function here. So I'm going to minimize the catalog. And then now, if I go, sorry, on the extension node, you will see that you will have this port that represents the connectors on the equipment side. So for this demo, I'm going to place one. So I'm selecting like P1 in this case. I do place in view. So I'm selecting the location on the equipment. And then I can modify representation. And I say I want to display the pin. So you can select all the pin or just a few of them. I say click OK. And now you will see all the pins. I decided to show all the pins for this connector on the equipment side. So now in the second time, I'm going to place the connector from the harness side. So same thing, I go back to the catalog. And then I'm going to use a different chapter because in a way to be well organized, it's recommended to use different chapters. So I have one for equipment, I have one for wires, splices, and I have one for 2D presentation for connector. So I'm going to use this connector here. So you just place it in space anywhere on your diagram. And then you have different options if you need to rotate the connector, the symbol, sorry. Now this time I want to display the pin. So I want to display all of them. So you select the first one, Shift key. Yes, you click OK. And then you want to link it to the connector on the equipment side. So you click on it. And then you can enter the instance title or instance name of the connector. You validate, and then you will see the connector. And now this connector, it's linked. The connector from the harness side is linked to the connector on the equipment side. And so all the text you can see here, they could be managed. So in this demonstration, what we are showing, it's the instance name of the connector. And here we decided to show the part number or the reference or the corresponding part in a physical model. So you will see later on in a demo what I'm talking about. And now for the next step, I'm going to place two cables. So I could place it from the catalog because they're in a catalog, but in this case, I'm going to show different techniques, or I will be placing the cable directly from the diagram because I want to reuse the existing one. So in this case, I could find the cable here. So these cables, they are part of harness one. So let's say I want to place the first one, which is a twisted pair. So there is a function named create from existing reference. And then instead of going from the catalog, I select it directly from the tree. Now I'm going to enter the new instance name. I validate. Now you will see that for this twisted pair, so it's a cable with two wires, a red one and a black one. So the next step is to select the pin on the first connector and the end of the wire. So I'm selecting the second pin on this connector. And as you can see now, you add these two wires. So now if you compare the existing one and the new one, the title of the wire or cables has not changed yet. So it's coming later because we have some rules that allow you to rename the wire. So I'm going to move it so you can drag it where you want, same thing. And if I'm correct, I think there is an enhancement coming that will allow you to move these two wires in the same operation. So now I'm going to place the second cable. So same thing, I'm going to use a create from existing reference function. And I will use these 3 wires twisted and shielded cables. So same thing, I enter the new instance name. So you can see your white, black, and yellow wires part of this cable. So I'm going to select the pin on connector 3, and I'm going to select another pin on connector 6. So same operation. I'm going to modify the positionment of the wire. So I will zoom in a little bit after I'm finishing moving this one. So as you can see, you have 2 grids. You have the main grid and you have a smaller grid here. So that will allow you to do the snapping, and all that is because I'm using this grid snapping function that will help you positioning anything, equipment, connector, wires, and cables on a diagram. So now I'm done creating this connection between these two connectors. So there is one thing that I'm going to do now. It's to rename these 5 wires based on existing rules. So this is, we created our own rules, but depending on your naming convention, the rules can be updated. So now, as you can see, if I zoom in, this is the rule. So in this case, we decided to use the name of the cable, to put the gauge and the color of the wire. But like I was saying, it's all depend of your naming convention. Now, the next step is to assign this connector and these 2 new cables to harness 1 here. So there is something called BI Essentials that you can access from the toolbar, from the Tools tabs. But since it's something that you will use very often in your design, you can add it to your action pad. So you don't have to switch between tabs all the time. So in this case, I'm going to use the function called Electrical Harness Link Review. So there is this color coding explanation telling you if your wires or equipment or connectors are linked. As you can see, as I place this connector and these 2 cables, they are not assigned to any harness yet. So that's why you have this color not linked. So what I'm going to do now, I'm going to leave this function, and under edition, still part of electrical system design, I'm going to go to the function called harness content links. So I'm going to select harness 1. So the connector will be highlighted, so you can see it in a tree, on the diagram, sorry. So you have 5 connectors. And now you are not selecting the cables. I'm just going to select connector 3. And as you can see now, by selecting connector 3, so the connector has been added under harness 1, so it belongs to harness 1. And these 2 cables, cable 6 and cable 5, now they are reporting to harness 1 because they belong to harness 1. And just to make sure that the function works, I'm going to run one more time the harness link review command. And you can see now the color change because now the 2 cables are linked to the harness. And if you even click on one wire or the cable, you will tell you that this is part of this cable or wires belong to harness 01. So that's for the work done under electrical system design in the generation on the wiring diagram. So now the next step is like I'm changing hat now, and now I'm going to switch to the 3D routing. So as you can see, we have this wing. So we have, as you could see in a diagram, we have these 3 equipments. So 2 equipments, they have only 1 connector, and then you have this equipment with 3 connectors placed onto it. So now in the next step, so first I have to change of applications, and I'm going to go to the electrical 3D design apps. So I don't need the action pad in this case. So now here, if I expand the tree a little bit, so you have the wing here, and then you have another product, and in this product you will have the EG, which is called the electrical geometry, which is known in the CATIA V5 as geometrical bundle. And then you have the EPS, which is where the conductors and wires will be routed. And then I have another product where I'm storing all my equipment. And then you have support as well that can be placed inside the electrical geometry or could be outside the electrical geometry. So in this case, I want to place the equipment that I just placed in a schematic. I want to place it in the physical model. So there is this function called logical to physical assistant. So I'm going to select it, and then I say I want to place the equipment. So now if you select preferences, you have different things you can analyze, different types. So in this case, I only want to work with equipment for now. So you could do everything in one shot, but just to explain how the function work, I prefer to do it in several steps here. So I'm going to select equipment, and then, so let me scroll down a little bit so you can see the screen. So I'm going to select the analyze button here. And then the tool is going to, the software is going to look at the diagram and look information regarding this equipment. So it's find it here. So I select it. So now you can see it in a tree and say, yes, I want to place this equipment. So you have this function to say set parents. So the set parents function is to specify where you want to instantiate the equipment in a physical model. So you do this, and then I'm going to select this product. I validate, and now you have different options to place the equipment. So I'm going to select let you place manually. So in this case, you see the equipment has been placed at the XYZ00 of your installation, and then with the compass, you can move it to the approximate location. So you can move it, and then if you leave the command, you can always use a snap function, but for the demo today, I think we are good like that. So now it's placed. As you can see, you have the equipment now stored under the dummy equipment physical product, and the status changed to green. So I'm going to close the function. You can do update. And then as you can, and as well too, I need something I need to specify. So everything that linked between a logical model and a physical model, an implement relation has been created. So if I click here, it will highlight the 3D part, the 3D model, sorry, of the equipment, and as well up in the tree, the logical model. So it's nothing you have to do. It's automatically generated, but it's needed for the L2P process. So now the next step for me is to work on harness one. So same thing, I go back to the logical to physical assistant function, and this time I'm going to select harness one. I select preferences and I uncheck equipment, but I want to work on electrical device. So same thing, you run the analyze function. And everything is live. It's not a video, so it's real time. So in harness one, we have 6 connectors. 5 are already in place, as you can see. Now we need to place connector 3 that I just placed in a diagram. So I'm going to select connector 3, which is highlighted here. And now I need to specify same thing. Where do I need to instantiate connector 3 in a physical model? So same function, you select parent. I say I want to place it under electrical geometry 01. You see set parent. And now instead to use a let you place manually function, I'm going to use an auto place. So I'm going to slide a little bit the physical model. So I'm going to select place automatically. It's going to take a few seconds. And then you can see that the connector has been placed directly on equipment, the new one. So I'm going to close this function and explain why. So in fact, what we have in between logical and a physical model, there is a link based on these two parts. And as well on the physical model, there is what we call a cavity that has been defined on equipment, and there is a cavity connection point on a connector. And it's why they are connected together. And there is other thing too based on symbol, 2D symbol of the connector. In a 2D symbol of the connector, there is a function called a tab called predefined part number, and I enter the part number of the connector in a symbol. So I will show it at the end of the demo, so just to explain a little bit more how it works. But it's very simple. So now, since I have the connector in session, I'm going to extend this segment here. So this is like a regular routing method, like in CATIA V5, it's exactly the same thing. So I select route definition, and now this is point 16. So I say I want to connect, to extend this segment to this connector. So I will select add after. So I'm going to zoom in, and once I see the segment connection point, I select it. I click OK. OK again. Update. So now the connector is linked to the segment, and if I move the equipment, the connector will move, and therefore the segment will follow as well. So now that was for the placement of the connector. As you can see now, I have connector 3, that's instance name, and you have connector 5P, which is a part number, the reference of the physical model. So now the next step is I want to route the wires. So same thing. We are back with the logical to physical assistant here. So I'm going to select harness 1. And this time I couldn't check electrical device, but I keep it, and now I'm selecting wires. So same thing. Select the Analyze button. So now, as soon as the Analyze function is done, you will have 2 tabs showing. So electrical device 1 and the wire 1. So the electrical device 1 is all green because last few seconds ago I placed the connector in a physical model. So now we are going to work with the wire 1. So let me minimize the pad. So there is a little trick to be done with cables. So in order to see all the cables, you need to do this little trick. So now the next step is I want to route these cables. So I do a multi-selection. Same thing. Now, as same as before, you need to set the parent. So now I'm going to the physical model and I say I want to place these cables in this physical system, the EPS. So I click OK. And now I'm going to resize a little bit. Sorry about that. And I'm going to select the place automatically. So as you can see now, all the cables has been added to the physical model and in a physical system, EPS, electrical physical system. So they are not being routed here. As you can see the message, it says specs not routed. But you can see the connectivity for every cables from connector to connector. Now the next step is to go to the conductor routing assistant. So you could do it, I could close this window and access it directly from the conductor tabs, here. But in this case, since it's available now under the logical to physical assistant, I'm going to run it from here. So now you have all the cables here. I'm going to do a multi-selection. I'm going to route them. And you can see all successfully routed. So I'm going to close this. I'm going to close this one too. And as you can see here, the message changed to spec fully routed. But I'm going to do update. And I want you to pay attention to this segment. So I'm going to do update. And now the diameter of the segment change because we have a diameter assigned to every cables and every wire. So now by doing the update and by routing the cables, is going to resize the segment based on the diameter of the cable. And if you click on it, if you click on a cable, you can follow the path of the cable as well in a physical model. So imagine if you have to repair or replace the damaged cables, you can load your session, you can load the physical model and the 3D routing model, and you can see the in-space routing. It's very helpful when you have to do to replace damaged wires or add wire to an existing routing. So that was the L2P function. So now I'm going to touch the 3D routing, the flattening piece, of the process. So I'm going to hide because there is one more thing I wanted to show you since we are here. If I use the link review function, if I select, let's say, the connector, it will tell me this connector has 5 wires connected to it, which is like 2 cables and 1 cable with 2 wires and 1 cable with 3 wires. And you have all this information right here. And you select highlighted, it will help you to highlight the connector in the physical model in 3D and in a tree as well. So it's called link review. So now we have a few minutes left, so I'm going to work on a flattened model. So I'm going to, in a process, I don't need to have everything loaded here. So what I will do, I will load this product in a new app. So it's a product with the 3D routing and the EPS with a cable. So there is two different processes, like maybe then explain it. Both manufacturing, but I will show one. So there is so under electrical manufacturing preparation, we have two processes. One is a full size from board, or there is one called documentation process that I will be running now. So let me select the EPS while it's running. So the documentation process, it's something like if you want to flatten it, it's not full size, but you could like flatten it on a, let's say, A3 or 11 by 17 format. It's something that the dimension will be automatically created. You will see that we'll be creating tables as well with a wire list that will be displayed. You can have a phase view as well of the connector if you need to. And I've seen some customers, they use it sometimes because if they want to do some inspection, let's say in a car or on an airplane, it's something easy to carry with you because it's a smaller size format, but you have all the information you need. So I need to click on, sorry about this one. So in this process, the flattened model will be created and a drawing will be created as well. So everything I'm doing today, this live demo, it's on 22x on the cloud. But it's the same process on premise, you know. Almost there. There you go. So that's a flattened model. So we came from this 3D routing, and then you have this flattened model automatically created, and now the drawing as well. So as you can see, you have, so in this case, we decided to show the, so I can move it. So we decided to have the 3D representation of the harness, the projection. But if you don't want to have the 3D projection, you could have a symbol as well. So in this case, we decided to have just a few columns, but in the first column, it's a connector instance name, the pins. Second column, it's the two from the wire, the two connection points. So that means the cavity on connector 6 and the name of the wires going to that connector. So you have the phase view. You can see you have all dimension created. So this special font here, it's because it's a covering. So depending on the type of covering, you could apply different fonts. So as you can see, I have this dotted line here. I have a regular line for this coverings here, protective covering, so same thing. So you can move these things around. So it's a very simple harness for this live demo, but it's we can add way more information. We can even print like a bomb, E-bomb, and place it on the face of the drawings if it's needed. So, and in that case, we have two supports that were part of the harness, so they are displayed here. So if you don't want to display the support but show a symbol, you can replace it by a symbol. So, and everything is managed by what's something we call a GVS, Generative View Style, something was already available in CATIA v5. So that's it for my live demo. I think I need to give the floor back to Zen. That's correct?
Yes, thank you,
Yeah.
Pascal.
Here we go, Zen. You have the floor.
All right. All right, thank you, Pascal, and thank you for doing this live end-to-end demo. So in summary, with 3D experience, electrical engineering, we are able to deliver a complete wire harness lifecycle management system based on the 3D experience collaborative platform. It provides an intelligent electrical system design environment and the integrated approach for 3D design and efficient manufacturing documentation solution. And through acquisitions, multi-brand collaborations, and the key customer engagements, we are expanding the scope to ensure the full traceability from the MBSC system of systems all the way down to manufacturing operations under the full configuration management engine offered by the platform. We look forward to collaborating with our customers to validate and further improve our processes as always. And this concludes our presentation and demonstration today. Thank you so much. So I should give it back to
Give it back to Kenya. And if anybody has any questions, please go ahead and fill out some questions in the chat box. I do have a couple of questions already. So please go ahead and ask your questions, and we'll get through these as quickly as we can. So the first question I have for the two of you is, can CATIA Electrical provide point solution functionality for companies that do not want to adopt the 3D Experience platform?
All right. So as you can see today, we have an offering that is cloud, and this allows customers to quickly implement any solution, not just electrical, but any CATIA or any Dassault system solutions on the cloud without the IT establishment in on-premise. And this cloud environment can be turned on within a few days, and give you a full out-of-the-box environment to work on designs immediately. So you don't have to adapt the 3D experience for platform, and you can use for example the schematic tool on the platform. And with this tool, you are able to export the results into drawings or into different tables such as wire list and power list to feed other applications as needed.
Okay, here's another question. How has 3D Experience CATIA Electrical evolved from the V5 days?
Pascal, do you want to answer this question? I mean, you have lots of experience on V5 also.
You want me to repeat the question, Pascal?
I was muted, sorry. No, I understood the question. Thank you, Susan. No, to me, the main thing is like, I've been a very V5 user heavy since R7 and R14 for electrical, but to me, the main thing is like, not on a platform you have this full integration, the full end-to-end process. Because when I was a V5 user, you know, it was like mostly from 3D to manufacturing, but now to be able to have the schematics, you have a fully integrated process. Like I just show you, before I couldn't do that. Before you have to use a external system or design Ecad system, and then you have to use a bridge, or you have to export a 3D XML. It was not very friendly process, you know. But now the fact to have everything on one system, so you could have, like I did, you could have the same user, like for a startup or small company, you could have the same user do do the end-to-end process by himself, so you don't have to have like a heavy PLM organization behind it to manage everything, So to me, that's the main thing. And like Zen was saying, on the cloud, it's very easy to manage, Anytime there is an upgrade coming from Dassault system on the cloud, you don't have to wait. It's coming right away. So like I get an update almost every week on the cloud with new functionality or fixes, things like that. To me, it's even a documentation process that I'll show you. It was not available in CATIA V5. It was a regular form board generation, what you used to call a EHF in CATIA V5.
Okay, thank you, Pascal.
You're welcome.
We are running out of time. I do have one more question, but I think I need to get to, well, I have two more questions actually.
Sure.
One of the questions was, this was the first seminar or webinar I was aware of. How can I attend past webinars? There's two ways. You could either send me an email, and I'm Susan up on the board up here. Send me an email and we can get you hooked up to the balance of the other classes that we've presented. Or we also have a YouTube channel that has all the classes up there. So you could go to our YouTube channel as well. I don't want to miss anybody. I want to give out the $50 gift certificate, and the winner of that gift certificate is Gary Govin. So Gary, if you would, send me an email and let me know that you were the winner, and we will get you hooked up with a $50 gift card. Next slide. So just wanted to let everybody know that the next class for Katia University is going to be on fasteners in automated manufacturing process. It's going to be on March 31st, 2022. So I just wanted to make sure I got all this in before any of you had to run off to another meeting. But I do have a couple of other questions if people want to stay on for a minute more. So let's get back to the last couple of questions that we have. How does it handle splices? Is a question we've got.
All right. Let me try to answer this one. I mean, so since you're asking this question, assume that you are in the automotive industry where the splices is mostly managed by a supplier. So when you are doing design in CATIA, of course, in a logical definition, you will define the splices. And in the physical design, you want to at least approximately position the splices in the 3D, because this will allow you to make sure that your splice is not positioned in a zone where, for example, the bend radius is significant, or it's in an area you have environment constraints that prevent a splice to be placed there. However, these positions can be updated further from the manufacturing or from the system design in a follow-up process. Actually, we are in the process of enhancing splice positioning capabilities with a fully automated process with inputs from the requirements. Soon will come in a few months, we hope.
Thanks, Zen. And here's the last question I'm seeing. How does 3D Experience CATIA Electrical collaborate with third-party Ecad solutions?
Well, so the option is you can switch to Katia Ecad. No, just kidding. Just kidding. Of course, I mean, we know that it's common for a company use Ecad tools, and they may not want to switch immediately. There are several ways to collaborate with Ecad, and we provide one is through what we call the spreadsheet editor. And this is a simple way of taking information as a spreadsheet, and such as a part list or a wire list, and to be imported into 3D Experience, either to directly drive the physical design or to generate the logical definition on the logical layer in the platform. And then if you are working directly with the physical design, this would you could use this to place objects in the 3D directly. And on the manufacturing side, we support the industry standard of KBL export, which is accepted, readable by many Ecad tools out there. This will give you a chance to import the topology of the 3D design into the 2D tools that you have.
Okay, thank you. Well, that's all I have for questions right now. Again, I want to thank everybody for coming today to the Katia University class number 6, sorry. And again, I want to just remind you that class number 7 is coming on March 31st, and it's all about fasteners and automated manufacturing process. So with that, I'm going to end the session and thank you once again, everyone, for attending. Goodbye.